Hello everyone, welcome to the Algebra 1 Semester 2 review packet here with Mr. Wagner. We're going to go through all the problems here. My advice to you, make sure you're trying all these yourself first, and then only refer to this video or the answer key if you're one of my students posted on our website after you've tried them. You can take some hints here, but make sure you try them first. And starting with number 1, it looks like there's an issue here. I don't think, nope, that's just like that. So on your picture, it should look like this. So starting right here, and you got more points there, and you got more points there and there. So number 1, we're trying to get that parabola, the equation for that parabola in vertex form. Vertex form, hopefully you remember, is f of x is equal to a, the scale factor, and then x minus h squared plus k. So we're going to put it in that form. This h and k is your vertex. So if we look here, the vertex is right here at 2, negative 1. 2, negative 1, that's the vertex. So we're also looking at the way it opens. That opens down, so a is going to be negative, and it opens at a normal rate, or goes down at a normal rate. Over 1 and down 1 squared. Over 2 and down 2 squared. So we would say negative, and a is 1. So you could just say negative or negative 1. And then you're going to have x minus h. H is 2, so x minus 2. Remember, in the parentheses, it's always the opposite of that x value, and then squared. And then k is negative 1, so it's plus a negative 1 or just minus 1. On this one, you have your vertex right here, and that point is negative 3, 1. And so from there, we have this opening up now, so a is positive. And it's opening up at a normal rate. 1 and 1 squared, 2 and then up 2 squared. Same thing going backwards. We have then 1, or just a as a blank spot. And then you would have x minus h would become x minus negative 3, which is x plus 3. The opposite of what you see for the x value of the vertex goes there. And then we would have plus 1 after that. Looking at number 2, we're going to graph this now. If we look at this, that tells us that a is negative 1, and that means it's opening down at a normal rate. So if a is negative 1, we've got that. We'll graph that after the vertex. We'll graph the scale factor part of that. So the vertex itself, though, is hk, and again, it's the opposite of what you see for x, and the same as what you see out here for the y value. So 4, 5. If I go over 4, up 1, 2, 3, 4, 5, there's my vertex, and it's opening down because of that negative sign right there, and it's opening down at a normal rate since that's like a negative 1. So over 1, down 1 squared, over 2, and we're going down 2 squared, which is 4. If I went over 3, I would go down 3 squared, which would be 9. So 6, 7, 8, 9, I would have another point down there. And then this other point, I could go off the graph a little bit there. Not my best graph ever, but I'm doing the best I can here in terms of connecting those dots. That's the basic shape right there. And number 3, using this, answer the following questions. Identify the coordinates of the vertex. Easiest way to do this is to say negative b over 2a. To use that to find x, and then plug that in to find y. So the vertex values, I'll work that out down here. The x value is negative b over 2a. A is right here, b is right here, and c is right here. So we're going to use those 3 values, and b is 4, so you'd have negative 4 over 2 times 1/2. That'd be negative 4 over 1, which would just be negative 4. So that's our x value of the vertex, so I could fill that in right here. And then take that, plug it back into the formula to get the y value of the vertex. So f of negative 4, you'd have 1/2 times negative 4 squared plus 4 times negative 4 plus 7. That's going to equal, this would be 16, because you're squaring the negative, so positive 16 times 1/2, that's 8. This is minus 16 plus 7. You have negative 1 if you put that all together. So negative 1 is the y value of that. And then if you make a sketch of that, that's a great idea, I think, to help you answer B through D here. That's the vertex. and then it's going to open up because this is 1/2. It's a positive value for a. So this isn't necessarily to scale, but that's the general trend of the graph here. That's my vertex at -4, -1, and it's going up. So the axis of symmetry would be the line going through the point right there. That's always x equal to the x value of the vertex. So x equals -4. And does it have a maximum or minimum? Clearly, since it's opening up, we look at the picture, a sketch of that, we have a minimum value right there. So it is the lowest value on that graph. And then the range of the graph, this is all possible y values. So all possible y here. And y, the lowest it gets is right there at -1. Anything above -1 is an option. So y is greater than or equal to -1. If it was opening down, we would say less than or equal to whatever the y value is instead. Let's take a look at number 4. So here, using this equation, we're going to identify the coordinates of the maximum. So that's, we're thinking here vertex when we see maximum or minimum with these kinds of problems, with quadratic problems. So I'm going to use that -b/2a idea again. Here you have your a. It always includes the sign, so be careful to include those negative signs if they are negative. So -b/2a is going to become -12/2 times -2. That's -12/-4, which is 3. And then we're going to take that to find the y value there, plug it back in. -2 times 3 squared plus 12 times 3 minus 16. Excuse me, this would be 9 times -2 would be -18 plus 36 and minus 16. If we put all that together, it looks like we've got 2 for our y value of the vertex. So the coordinates of the vertex, 3, 2. And then we'll put that here in the table. So 3, 2. And then complete the table to the right. You can use a calculator to find the values for y. And so I've done that prior to this, and I plugged this into, if you have a button that says table on your calculator, like the yellow calculators that we have in my class, you can just plug that formula into the equation after hitting table, and then you can quickly see all those values. But you could also do each one of these, 1, 2, and 4, and 5. You could do that by hand. You can do that one at a time as well in the calculator. But you should get these values here. 0, you should get -6, and we should have 0 here, and -6 here. And notice the symmetry there. We should have symmetry with parabolas like this. So is the curve wider than normal, narrower than normal, or normal? So we look at this value right here to determine that. Now if this is equal to 1 or -1, it's normal. So that's not what we have here. It's either wider or narrower. Basically think, is it going to grow faster or slower than normal? If this is greater than 1, it grows faster. So if it's growing faster, it's going to be skinnier. Then maybe we could say this is the normal one. If it grows, or if this is less than 1, or in between -1 and 1, then it's going to grow slower. So this is where a is greater than, the absolute value of a is greater than 1. This could be where a equals 1, and this is where the absolute value of a is less than 1. So we have something growing faster, so it is going to be narrower than normal here. So narrower is our answer there. And then identify the solutions from the table. The solutions, that's always where the y value is 0. We're talking the x-intercept. So the y-intercepts, excuse me. So the y-intercepts, looking at the table, where does that actually cross the graph? Where does the y value equal 0? That's right here, and that's right here. So we have 2 and 4. Or you could say 2, 0, and 4, 0 as well. And I'm misspeaking myself here. This is the x-intercepts, where it crosses the y-axis, x-intercept. So I had that right the first time around there. And then let's move on to 5. So change standard form to vertex form by completing the square. So completing the square, we're going to put the first two parts together in parentheses, and we'll rewrite this. We've got x squared minus 10x, and then include a blank space, include another blank space, and 20. And then this value right here is always going to be negative b over 2 squared. So if you take b as negative 10, you divide that by 2, you get negative 5, square that, and you get positive 25. And then right here, we can't change what this equation is, we can just change how it looks. So to keep it balanced, I just added 25 to the equation. I'd have to subtract 25 here. If there was something in front here, that would actually be something else in disguise. We'd have to think about what we would get distributing whatever was out in front through, but it's not. There's nothing out there, so we can just say negative 25 right there. And then from there, we can take this b value, divide it by 2, and that's what goes right here. This is just b divided by 2 right there. If you were to multiply this back out, distribute that back out, you would get what you started with. And then here we would have minus 5. So we're trying to change standard form to vertex form. We've done that. We now know the vertex would be the opposite of what you see here, positive 5, and then negative 5 for the y value of the vertex. And if we do the same thing over here, we'd have x squared plus 20x blank spot plus 98. You're going to divide this by 2 and square it. That'd be 100. That is 100. It's not something in disguise because there's nothing out here. So we just put the opposite right there. And then do the same thing. Divide this number by 2. And that goes here. If you squared x plus 10, you'd get what you started with. And put those two things together, we have f of x being that. The vertex for this equation would be negative 10, negative 2. Number 6, so the graph at the right shows the height h in feet of a small rocket t seconds after it is launched. The path of the rocket is given by this equation, and we're going to assume no air resistance. Use the graph to figure out a through d. So if we look, how long is the rocket in the air? If we look at the graph, this is the time in seconds that that rocket is in the air. It looks like it starts at 0, goes up, reaches its maximum at 4 seconds, and then comes back down, hits the ground at 8 seconds. So how long? 8 seconds. And then about how high is the rocket after 1 second? So if you look at 1 and go up, it looks like it crosses right about there or so. And so you might estimate that to be about 108 perhaps. Each grid line looks like it's worth 10 here if you count the number of grid lines there. So 108, maybe 110. The actual answer from the equation ends up being 112. So if you said 112, I would take that too. That would actually be the correct answer. But if it says about, as long as you're pretty close to that and look at the graph, you're good. So after 6 seconds, about how high is a rocket? If we look at 6 seconds, that point is drawn in right there. And that looks close to 190. Using the equation, you would actually get 192. So anything close to those two values would definitely be acceptable. If it says about, you are estimating. And then are you having the rocket going up or down at that point? So it went up until 4 seconds, and then it started coming back down. Definitely coming back down. It's on its way down. So you would say it's going down at 6 seconds. And then using the equation, find the exact value. So we're going to use the equation now to figure out the exact value at 2 seconds. So you'd have the height at 2 seconds is equal to negative 2, or negative 16 times 2 squared plus 128 times 2. And this would be negative 16 times 4, that's negative 64. This would be 256. Put that together, you've got 192 feet. And so if we look at the graph, 2 seconds, that seems like a reasonable estimate there, a reasonable answer based on what you can see there in the graph. Let's take a look at the next problems together. Quadratic formula. So you got to know the quadratic formula as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, or a little less flowery, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Pop goes the weasel tune right there. It can help you remember that. So if you are using this, you have to get one side equal to 0 first. So I subtracted 12 from both sides. Doesn't look like there's any GCF I could factor out to make this simpler. So at that point, it says use the quadratic formula. I'm going to do that. This would be my a, this would be my b, and this would be my c right there. So I'm going to plug it into the formula. I've got x equals negative, opposite of negative 9. And then with these negatives, make sure you include those in parentheses. Otherwise, if you're not squaring the negative, you're going to get a negative value instead of the positive value that you should get. So here, negative 4 times 2 times negative 12, all over 2a, all over 2 times 2. So this would be 9 plus or minus 81. And negative times a negative here would make that positive. 4 times 2 is 8, and then 8 times 12, you have 96 here, all over 4. And so 9 plus or minus, that would be the square root of 177 over 4. At that point, it says round to 2 decimal places, so you could put these two options in the calculator. 9 plus the square root of 177, all divided by 4, or minus. And those two options looks like would give you 5.58 approximately, or negative 1.08. So those would be your two answers. And then here, this one's already equal to 0, so we're good to go. You could divide everything by 2 here if you wanted to. You could factor out the GCF of 2 and then have some easier numbers to deal with. You could do that, or you could just leave it like it is and use A is 2, B is 12, and C is 10. I'll do that, but again, dividing everything by 2 would work just as well, if not even a little more efficiently, or a little easier to deal with the numbers. But negative 12 plus or minus, this is x equals negative b plus or minus the square root of b squared. So 12 squared minus 4ac, 4 times 2 times 10, all over 2a. This would be negative 12 plus or minus the square root of 144 minus 80, all over 4. That would be negative 12 plus or minus the square root of 64 over 4. And that's a perfect square. So you've got negative 12 plus or minus 8 over 4. Negative 12 plus 8 would be negative 4. And divide that by 4, you'd have negative 1. Negative 12 minus 8 would be negative 20. Divided by 4 would be negative 5. So those are your two options. Number 9. In the year 2007, suppose the price of a stamp was 38 cents, and then in 2014, the price is 52 cents. We're going to try to come up with a linear equation here. So here I think it's helpful to make a little table, and we're saying 2007, the year. Put that first because the price will depend on what year it is. The y depends on the x. So here we're going to have 38, and then here we're going to have 52. So my x values represent the year, and this represents the price of the stamp. And then we can use, to find a linear equation, we can use point-slope form here if we're given 2 points like this. So to find the slope, just do our y2 minus y1 over x2 minus x1. You'd have 2014 minus 2007 over 52 minus 38. That'd be 7 over 14, which would be 1/2 right there. And yes, I felt like I was doing something wrong there. My y's are the price, so I should have flipped this around. I'm sorry about that. So we should have 52 minus 38 on the top. That's better. And 2014 minus 2007 on the bottom. That's 14 over 7, which is 2 over 1, or just 2. So it's going up by 2 cents every year, it looks like. And then to come up with the equation, we can do y minus y1 equals m times x minus x1. Point-slope form will do that for us here. So pick a point, any point. I'm going to pick this one. I could have picked that one. Either is fine. And then y minus y1, the y value I chose was 52. The m value is right there. The slope is the m value, and then you've got x minus, and then the corresponding x value that went with the y value you chose. From here, we'll get this into slope-intercept form, 2x, and then minus 40/28. If you add 52 to both sides, you'll have a slope-intercept form for that equation. Looks like that'll be 2x minus 39/76. Excuse me. Hopefully I'll be able to make it through this. I've gotten over being sick. like a week ago or so, but I still got that lingering cough. It seems like it won't go away. So from here in 2016, since we're using the actual years and not years after something, I can just plug that in directly for x. So I'm going to say y equals 2 times 2016 minus 3976. This would be 4032 minus 3976. So we're going to assume that the price of a stamp in 2016 would be 56 cents if this trend continues in a linear way. Number 11, we're going to shade the enclosed area of this inequality and this one. So we have, looks like a linear inequality here. I'll rewrite that there. And then here we have a quadratic one. So let's focus on this one first. We're going to try to get y by itself, get it into slope-intercept form. So negative 2y is less than or equal to x minus 6. If you divide by negative 2, we're going to have y, and then remember, if you divide or multiply everything by a negative with inequalities, got to switch that sign. So we have negative 1/2 x minus 3. And then looking at that, you should notice that the slope is going to be negative 1/2, and the y-intercept is going to be negative 3. So if I graph that, I start at negative 3, and from there I could go down 1, right 2, that'd be a negative slope. Up 1 and left 2 would be the same slope, just going in the opposite direction there. So we've got a line that looks like this, and I'll sketch a line there. You should use a straight edge when you draw your lines, but I'm just trying to give you the idea here. And man, I just noticed a mistake here I made again, because I had that's why my negative blended into the 2 there. So that should be positive 3. Which would adjust my graph here. Should be going through positive 3 and then down 1, right 2. So it should go through those points instead. So we'd have, and this is a solid line because it's less than or equal to. If it's just less than or just greater than, then you have a dashed line instead. And we would be shading, looks like greater than, so shading above that line. And then this other one, we could think of this is in vertex form already. So the vertex is going to be the opposite of that for the x value, negative 3, and then the same as that for the y value, 6. So if I go back 3, up 6, I've got a point right there. And then this means it's opening down. That's a negative sign, and it's like an invisible 1 right there. So down at a normal rate. So over 1, right 1, over 2, or over 1, down 1 squared, over 2, down 2 squared, which is 4, over 3 would be down 3 squared, which would be 9, and so on. And so the same thing, symmetry on the other side. And this is less than or equal to, so this would be solid as well. And since it's less than, same idea works with parabolas. We're going to shade below whatever we have instead of above. So what our solution would be this shaded area. We're saying below that, but above the line, this is the area that they would have in common there. Number 12, we have this, we're trying to determine if it's arithmetic or geometric. If it's arithmetic, there's a common difference. If it's geometric, there's a common ratio. We can clearly see that there's not a common difference. We're not subtracting or adding the same thing every time. So this one is geometric. So we're going to find the common ratio by dividing the second term by the first, or the third term by the second, or the fourth term by the third. You can do any of those things. If this is going to be a common ratio, those will all be the same value. So this is negative 32 over 1/28. That's one way to figure this one out. That's going to be negative 1/4 or negative 0.25. And then write an equation that describes the behavior. We came up with this equation for exponentials, for geometrics. In other words, that's just another way to say an exponential type of relationship. So we have the initial y, and then you've got the ratio, and then you have x minus x1. That's the way we had talked about it most recently. And so we have the initial y. Well, you can pick really any points here that you want to, just like with slope, point slope form back here. It doesn't matter which ones you choose, but let's pick the top one just to make it hopefully the easiest to deal with. So if I'm going to choose this as my point, I would have that as my y1, that value right there. My ratio I figured out right there was negative 0.25. And then x minus x1 would be x minus, and then the corresponding x value of the point you chose. So x minus 0, you could write it like that, or you could just leave out the 0. We wouldn't need to write that. So it could look like this. That's even a better way to write it in that case. If you had chosen 8 and 2, then that would be an 8 and that would be a 2 instead. Those would still be, or that would still be a correct equation. You could do the same thing with any one of those 5 coordinate points there. And then 15, if the pattern continues, predict the 10th term in the pattern. And this is asking you to round to 7 decimal places. So the 10th term in the pattern, you'd have 128 and then negative 0.25 to the 10th power there. We're going to say that's the 10th term. And if you put that into a calculator, it looks like you'll get about this. So 0.000, I could say approximately there, and then 1221. If you round that to 7 decimal places, that's what you should get there. Let's look at number 16 through 19 together. So a very similar one here, but this one, if we look at the pattern here, we're adding 6, we're adding 6, we're adding 6 each time. So this one is arithmetic. Back here, we were dividing by 4, dividing by 4, negative 4, and so on. So that was a ratio of negative 1/4. This one's a common difference, arithmetic, and the difference is always that second term minus the term before it, minus the first term. So negative 7 plus 13, which would be 6 in this case. And then an equation that describes that behavior. Here we can use point slope form now. So this is like my common difference is like my slope. And so I would plug values in. I'll go with this point right here. I could pick any point I wanted to. As long as the x and the y are matching, I'll get the right equation. So y minus y1, the one I picked, would be negative 13. And then 6, x minus 2. So that would be the point slope form. If I wanted to get slope intercept form, I could distribute that 6 through to both pieces here. So I'd have 6x minus 12, subtract 13, and you'd be left with y equals 6x minus 25. And then from there, the pattern continues. You're going to predict y when x is 25. So you'd have y equals 6 times 25 minus 25. That's 150 minus 25. So 125 would be the predicted value there. Looking at 20 through 22, let's use this. So the growth or decay value. To find that, you always look at this and determine how far away from 1 that is. So this would be the same thing as 0.8, which would be the same thing as 1 minus 0.2. So think about that when you're determining the growth or decay value. So the growth or decay value is right here. It's always whatever you have, 1 plus or minus whatever that is. That's your growth decay value. So that's going to go right there. That is 0.2. And then that as a percent, that's a decay value because it's less than 1. So as a percent, that would be 20% decay. If you said negative 0.2 and negative 20%, I would take that just as well as saying 20% decay and 0.2 for the decay value. And then the initial value is that one in front right here. This is always your initial value. We often refer to that as a sub 0 right there. And so this initial value would be 3. Same thing works up here. Look at that. That is how far away from 1. That's 2.4 in the positive direction away from 1. So that's going to be your decay factor, decay value right there. This would be 2.4. That is and that is growth, and that is a percent would be 240%. The initial value, the value in front there, 11.3. 26 says a car is purchased for $24,000, expected to lose or depreciate at a rate of 8% per year. And then after how many years will the car first? How many, that was a typo there, how many years is the car first less than 15,000? So you would be, you'd be using this formula. You'd have your A0, so the initial value in the front, and then times 1 plus or minus the ratio, the growth or decay rate, and then to the t power. We're not compounding here, so we don't have to divide by c and multiply by c there and there. So we have 1, it's depreciating at a rate of 8%, so we'd have minus 0.08, and then we're trying to figure out after how many years that is. So you would say that's x or t for years, time and years. And then we're going to look in a calculator using the table button on our calculators. We'd use that here to figure out when this happens for the first time. And so the first time this happens, if you use that table button in the calculator, the first time that the value using this expression typed into the table, the first time that becomes greater than, or it becomes less than or equal to 15,000 is at 6 years. So this happens at 6 years. So you would say that is your answer. So this happens, you could really say less than or equal to, rather I would say the 15,000 becomes greater than or equal to that. So this first occurs at 6 years. Before 6 years, it's still worth more than 24,000, but after 6 years, it becomes worth less, or more. It's still worth more than 15,000, but after 6 years, it becomes worth less than 15,000. 27. You deposit $4,500 in an account, 8% interest. So here's your initial value. Here's your interest rate. And it's earning interest, so you can think of that as positive 0.08. And it's compounded quarterly, so C is going to equal 4. Monthly would be 12. Yearly would be 1. Annually would also be 1. Daily would be 365. And then at the end of 35 years, think of that as your T, how much money is in the account. So we're going to use this formula right here, and we're just going to plug those numbers in. So 4,500, and then 1 plus my interest rate is 0.08 divided by my compounding amount 4 times a year, and then we do C times T here. So 4 times 35 right there. You could simplify that before putting it into a calculator. That would be up to you, but that would be 0.08 divided by 4 would be 0.02. So you could have that, and then this would be 170. So if you want to put that or this into the calculator, either way is fine. Either way you do that, you're going to get approximately this, $71,984.10. 28. We're going to still use that idea, either this one here or this one here. We're going to use those for these next equations. And so an adult takes this much. That's my initial value. Takes that much ibuprofen, and then each hour the amount of ibuprofen in this person's system decreases by about 29%. So if it's decreasing by that, this is going to be an R value, a ratio value of negative 0.29. And we're trying to figure out this effective rate. We want this to basically be our Y value, our total value. After how many hours will they need to take another dosage? So we're looking for, when is this true? So we would be saying 200. When does that equal the initial amount, and then 1 minus the ratio to the T power? So again, use the table button here and figure out when that happens. What T value do you need to get this to be 200 or less? So really we're looking for when it equals that, or when this is greater than that. For the first time, that happens for the first time at, and I'm just referring to my work I had done before on this one. So this first happens at 5 hours. Excuse me. And then 29, your baby brother has an ear infection. There's 50 million bacteria in the left ear. So that is your initial value right there. The penicillin will kill 8%. So that's going to get rid of 8%. So we're going to think of that as our R value. And how many bacteria after 8 hours. So there's our T value right there. So this one, we're going to figure out what is Y, what is the total. And we'd start with 50 million. And then do 1 minus 0.08 to the 8th power. And if you put that into a calculator, you should get approximately this much. So 25,660,944 bacteria. And then how many after 1 day? We have to think of this in terms of hours, since that's what we have here. We got to keep consistent units. 1 day would be 24 hours. So we would have 50 million, and then 1 minus 0.08 to the 24th power. This is approximately 6 million. Still a lot of bacteria, but a lot less than you started with, that's for sure. That much bacteria would be left. 6,758,929 approximately. Let's take a look at 31. We're going to complete that table and plot the points for this. So for this one, I would put that into the table button in your calculator, put that equation right in there, and then figure out what you got from there. So I did that, and for 0, I'd get 3, because this would become 2 to the 0 is 1. 1 plus 2 is 3. This would be 4 here. 2 to the first is 2, plus 2 is 4. If it says on the exam that you have to show your work for this, then do that. Otherwise, you could use that table button on your calculator. This would be 6 and 10, and then going the other direction. This was 5 halves, 9 fourths, 17 eighths. This is about 2.125. It's exactly that. This is 2.25, and this is 2.5 down here. That will help us graph this a little easier. So negative 3, looks like my scale is going by 1 along the x-axis, but by 2 along the y-axis. So be careful as you plot this to keep that in mind. So if that's 2, that's 4, that's actually 6, 10 right there, and 14 right there, and so on. This would be negative 3, this would be positive 3. So that's just above 2 right there, and then this is just a tiny bit higher than that one. 3 is going to be, this is 4, so 3 is going to be halfway there, so we'd have to go about right there, and then 3, that should be right about there. 4 is going to be here, 6 is going to be there, 2, 6, and 3, 10 would be right there. So to graph this, it looks like that. And this growing exponentially. If it was decay, if this was going down instead, if this ratio is less than 1 but greater than 0, it would look like that instead. If you had this as negative, it would be flipped around instead. Let's take a look at 32 now. We're going to deal with a bunch of exponents. We're going to box in our answers, as we always should be doing, and then have only positive exponents. So when you have a power, something with a power, raised to a power, we're going to think about distributing that power through. So this would be negative 2 cubed would be negative 8. K squared cubed would be, we'd multiply those two numbers. 2 times 3 would be 6, and then d, this is like d to the first. So 1 times 3 is 3. So that would be what I'd have for the first one. Now we don't have a power to a power, we have something times something instead. So when we have just multiplication left, this is going to be just multiplied. So negative 8 times negative 1 really there, that's positive 8. But now we add the exponents when we're multiplying. So this would be k to the 8th, and then d to the 6th. And that'd be your final answer for that one. This one, we'd have this square. Think about really kind of distributing that. Negative 4 squared is 16. C to the c squared squared would be 2 times 2 there, 4. And then this is just d, so that'd be d squared. And then I have 2c to the 6th and d cubed. I can reduce this. This would be 8. This would go away, and I'd have 8 left there. Excuse me. And then this one would go away completely. I'd have 2 left for the power there. This one would go away completely. I'd have 1 left for the power there. So my answer would be 8 on the top, and then c squared d to the first, or just d on the bottom. For this one, you're going to really think of distributing that power. So k squared e squared times k e squared on the top, and then k to the 4th e on the bottom. And now we just have multiplication on the top, the numerator part at least. So k squared times k would be k to the 3rd, 2 plus 1 there. And then e to the 2nd times e to the 2nd, 2 plus 2 would be 4. So you'd have k to the 4th over e still on the bottom. Look for the smaller powers. You can cross those out. We got rid of 1 there, so get rid of 1 there. We got rid of 3 there, so get rid of 3 down there. So you're left with e to the 3rd over k to the 1st, or just k. Number 35, if you have a negative power like this, we can think of flipping the whole fraction around and making that a positive power. So that's what I did first with this one. So I can take the denominator, put it in the numerator spot, put the numerator in the denominator spot, and then just make the power positive. So from there, there's a couple different things I could do. I could actually distribute that 2 through to everything first, or I could reduce this and then distribute the 2 through to everything. I'm going to distribute the 2 to everything here. So everything is going to get squared. So this would be 4 squared, 16. And then a negative 4, if I'm squaring this, if I'm really thinking of distributing that power, I'm going to multiply those powers. So it would be negative 8, that'd be positive 6. This would be 2 squared 4. This would be 2 times 2, that's into the 4th. 4 times 2, d to the 8th. And then from there, if I want this to have all positive exponents, any negative exponents can switch places in the fraction and become positive. That's a rule of exponents that we learned. So this would be 16d to the 6th, and then 4 n to the 4th times n to the positive 8. Now if we move that to the other place in the fraction, and that still times d to the 8th. So if I put all that together, I've got 16d to the 6th over 4n to the 12th d to the 8th. So one more step here. I can reduce this to 4 and 1, and then there's 6 d's here, 8 there, so I'm going to get rid of 6 down there. My final answer for this one should be 4 over, and then 1 n to the 12th d squared. I don't have to write the 1 in there. I should just get what I see there. Number 36. This one, there's no power to a power, so I'm just going to multiply everything across here. 9 times negative 2, negative 18. X to the 3rd times x to the negative 5 would be x to the negative 2. Add those powers. And same thing here. Add those powers. It'd be y to the 7th. But no negative exponents, only positive exponents. So anytime you have a negative exponent, we could think of this as being over 1. That's got to switch places to make it positive, switch places in the fraction. So we'd have negative 18 y to the 7th over, and I don't want you to think that's an equal sign, so let me make that clear. Over, and then the x to the negative 2 would go on the bottom as x to the positive 2. So negative 18 y to the 7th over x to the positive 2. And then to finish this off here, anything to the 0 power, that's what we have here. As long as it's not 0, anything to the 0 power is 1. That's just a rule of exponents that you need to know. Doesn't matter how complicated this looks. If it's to the 0 power, it equals 1. And then solve for x on this one. So our tactic, our plan of attack for these kinds of questions, we want to get these bases to all be the same. So 27, a way to write that as a power of 3 would be 3 to the 3rd. And then here, if we're multiplying these together with the parentheses, that's the assumption, we're going to add the powers. We don't have a power to a power, we had just have multiplication in between with the same bases. So we would have 4x minus 3 plus 2x plus 3. This would be 3, and then you could combine like terms in the exponent here. That'd be 6x, and then these 3's would cancel each other out. So 3 to the 6x equals 3 to the 3. The only way for that to be true is if 6x equals 3. So we could just solve this for x, divide both parts by, or both sides by 6, reduce that fraction. That's your answer, x equals 1/2 there. Number 39 through 43, dealing with some scientific notation. So I think the easiest way to think about these is to actually draw and think about, count them as you go. 1, 2, 3, 4, 5, 6. You've got to move it 6 places there. So we have a 6, and then with scientific notation, if you move things to the right, you actually subtract from the power. So if I move it to the right, I'm going to subtract from the power. If you move it to the left, 1, 2, 3, 4, I'm going to add to the power. So this rewritten in scientific notation looks like this, with the individual pieces at least. And then we multiply stuff together. So 7 times 9, that's 63. And then times 10 to the negative 6 times 10 to the 4. We are going to add those exponents since we have the same bases, and we're multiplying in between. So this would be 10 to the negative 2. Now if we want to write this in the correct form, this number here out in front always needs to be in between 1 and 10. It can include 1, but it can't include 10. So if we move that one place to the left, usually we think of going to the left as being minus, but if we're going to affect the power, that's actually going to add 1 to the power. So moving to the left will add to the power. Moving to the right will subtract from the power. So we add 1 to this power, and you've got 6.3 times 10 to the negative 1. That would be your answer in the correct form. On this next one, we're moving it 1, 2, 3, 4, 5 right there, and we're moving it to the right, so that's a negative effect on the power. 1, 2, 3, 4, 5, 6 this way, so we're going to add 6 to the power there. So this would be the same thing as 2 times 10 to the negative 5 over 8 times 10 to the positive 6. Now we're doing division, so we need to divide those. 2 divided by 8 is 1/4 or 0.25. And then you have times 10, negative 5. If we're dividing, we're going to subtract those powers here. So we have negative 11, negative 5 minus 6. This is not in a correct form because it's not between 1 and 10 like we need it to be. So move it one spot that way to the right, and we would be subtracting from the power. So this is 2.5 times 10 to the negative 12. For 41, moving it 1, 2, 3 spots, moving to the right, we're going to subtract from the power. Move it 1, 2, 3, 4 spots there, moving to the left, we're going to add to the power. This is 5 times 10 to the negative 3. And this is 7 times 10 to the 4th. And then 5 times 7, that's going to be 35. And then we add those powers right there. This would be times 10 to the 1st. And now we got to get this between 1 and 10. So move it 1 to the left. And that's going to add 1 to the power. This would be 3.5 then times 10 squared as your final correct form. On this one, 1, 2, 3, 4, 5, 6, 7, 8. So we are saying that is minus 8 to the power. In that one, we are subtracting 4 from the power. So on the top, you have 4 times 10 to the negative 8. On the bottom, you have 8 times 10 to the negative 4. This would be 1/2 or 0.5. And then negative 8 minus negative 4 is the same as negative 8 plus 4, which would be negative 4. Boy, hope I can make it through the video here. My voice is starting to fail me a little bit. So we have moving that 1 to the right. That is going to be subtracting 1 from the power. So 5 times 10 to the negative 5. And then finally we have this one. We're going to move 1, 2, 3, 4 there, and moving to the left, so add 4 to the power. Here 1, 2, 3, 4, 5, 6. Moving to the right, we subtract 6 from the power. This is 6 times 10 to the 4th, and 3 times 10 to the negative 6. Divide these. You got 2, and then 4 minus negative 6 is the same as 4 plus 6. So you have 2 to the 10th times 10 to the 10th. That's already in the correct form. This number is between 1 and 10, so you can just rewrite that there. 44. We are going to simplify this. Distribute that through there, and you've got 5 x to the 4th, y to the 3rd. And negative times a negative makes that positive. Here we have negative times a positive. That's going to be negative 20. X times x is x squared. Y squared times y to the 3rd would be y to the 5th. For 45, we are going to distribute this through here. We have 8 times 3, 24. C squared times c to the 4th is c to the 6th. D squared times d to the 3rd is d to the 5th. And do the same thing, same approach here. That'd be 80. That would be c to the 5th. And that'd be d to the 6th. And then 11 times 8, that's 88. There's no variables here, so it's just c squared, d squared after that. On this one, we really have this part to do first. And then we're going to subtract this from that. So all multiplication, we're going to multiply before we subtract. 4 times negative 3 times negative 1. Multiply all those coefficients together, and you'd have positive 12. K times k squared would be k cubed, and then times k to the 5th would be k to the 8th. And then we'd be subtracting these three things multiplied together. 2 times 3 times 4. 2 times 3 is 6. 6 times 4 is 24. K cubed times k squared would be k to the 8th. And now these are like terms. You have k to the 8th and k to the 8th, so you can reduce, or you can simplify rather, one more step. 12 minus 24 would be negative 12, and then we'd have negative 12k to the 8th. Same sort of thing here. We want to put these together first and these together, multiply first, and then add. Remember PEMDAS. So look for all the x's here. We're multiplying all the x's together. X squared times another x would be x cubed, times 2 more x's would be x to the 5th. And then y, 2 more y's would be 3, 2 more y's would be 5. You have x to the 5th, y to the 5th, plus, and you have 3 x's times 2 more, that's x to the 5th. And then 2 y's times 3 more, y to the 5th. So you how many x to the 5th, y to the 5th pieces are there? It's like 1 plus 1 of those. You have 2 of those. So 2x to the 5th, y to the 5th. That would be your answer on that one. 48, any 7th degree trinomial. So 7th degree, that's the highest power. Has to be a 7. And then a trinomial has to have 3 distinct terms you couldn't combine together. So here's an example of this. This is just one example. I'm going to go with, keep it simple here, x to the 7th would be a 7th degree trinomial if that's the highest power. I could do 2x to the 5th. I could do 3x to the 4th. I could do anything else I wanted to do there. And then this third term just has to be different than 7th powers and 5th powers. It could even include more variables. I could include y's in there, but I couldn't have x being higher than a 7th power. So I'm going to go, why don't I even switch it up a little bit? I'm going to put a minus sign in there. It could have kept that plus, but I'll just say 5x squared instead. This is an example of a trinomial with a power or a degree of 7. And then here, 48, descending powers of x. Look for the highest power of x. That's that one to start. So this would be rearranged in that way, negative x to the 4th y squared. So we dealt with that one. And then look for the next highest power of x. That's this one right here. So we'd have, that's positive, 3x squared y. That one's dealt with. And then the next highest power of x is right here. I know this is a 5th power, but that's of y. There's no x's there, so this one would be next. 4xy squared, and then plus y to the fifth. That would be written in descending powers of x. Number 50, distribute and simplify. If we distribute, excuse me, distribute and simplify, we're going to distribute the x through to both pieces and distribute the -5 to both pieces. If FOIL helps you, you can think of that. We'd have x squared plus 7x for the first and the outside parts, and then the inside and the last, you'd have -5x minus 35. So we distributed. Now let's simplify. X squared plus 2x minus 35. For this one, distribute the 2x to both pieces and the 5y to both pieces. You'd have 2x squared plus 12xy, and then here you'd have 5xy and 30y squared. Combining like terms, you can put these two together. You'd have 2x squared plus 17xy plus 30y squared. For this one, that's the same thing as saying 3x plus 8 times itself. So if we distribute the 3x to both parts and the 8 to both parts, you'd have 9x squared plus 24x twice plus 64. Combining like terms gives you 9x squared plus 48x plus 64. Same idea here. Something times itself if it's something squared. Distribute the 6x and the -4y through to both parts. You've got 36x squared minus 24xy written twice. And then plus 16y squared. Combining like terms, you'd have -48xy plus 16y squared. On this one, distribute the 3x and the -9y to both parts there. You'd have 9x squared plus 27xy minus 27xy minus 81y squared. And that looks like these two things would cancel each other out. You'd have 9x squared minus 81y squared. And that should make sense. We have the difference of two perfect squares there. And so we'd take the square root of that one and the square root of that one. Put those two things here and here. One is plus and one is minus. And then finally for this one, distribute that through and that through. 3a squared times 3a squared would be 9a to the fourth. 3a squared times 2b squared would be 6a squared b squared. We've got two of those. And then this would be 4b to the fourth. Combining like terms, these are the like terms here. 9a to the fourth plus 12a squared b squared. You've got 6 of those plus 6 more of those plus 4b to the fourth. Number 56, we're going to solve this one. So solving this, we want to get this distributed through and this distributed through. We'd have 6x squared plus 12x equals 6x squared plus 24. So if I subtract 6x squared from both sides, they'll cancel on both sides. That's pretty handy. I have 12x then equals 24, and you divide by 12, you've got your answer. X equals 2. You can plug that back in and check to make sure that it works, and it does. The next one, 57, we're trying to find the greatest common factor, or GCF. So look at both of these. Look at the coefficients first. For 8 and 12, the coefficients GCF would be 4. Be the greatest common factor of both of those two numbers. And then we look at the x's. We have x squared and x cubed, so they both have at least x squared. And then we look at the y's. This one has a y, but this one doesn't, so I couldn't include that in a common factor, so this would be my greatest common factor. And then same approach here. Look at the coefficients. 15 is the largest number that goes into all three of those coefficients. Look at the a's. It looks like they all have at least one a, so we can write an a. Look at the b's. They all have at least 3 b's, so b cubed is part of the GCF there. 15a b cubed. 59, we're simplifying that expression. So we're dividing each piece really here by 7a squared b. So if I divide 7 by 7, I've got 1. If I divide a to the fifth, and why don't I do this work over here? I'm going to run out of space there otherwise. And I think I'll write it like this first too. So really we've got each piece on the top divided by 7a squared b on the bottom. So this is another way to think of this, and then we can reduce from there. So the 7s and 7, that'll cancel, and then cross out the smaller ones. You got rid of 2, so you got to get rid of 2 there. You got rid of 1, so you got to get rid of 1 there. Here that'd become a 7 and a 1. You're getting rid of 2, so get rid of 2 here. Getting rid of 1, so get rid of 1 there. You have left over a cubed, b cubed for the first part, for this part of the numerator, and then 7a squared b to the fourth. These are not the same as these, the same term, so we would just write it like that. That would be fully simplified. The same thing works here. You could say that this is 15a to the fourth b to the fourth over 3a squared b to the third minus, and then each term here being divided by that right there. So minus 3a to the fourth b to the fifth over 3a squared b cubed, and that minus 6a cubed b to the sixth, and then 3a squared b cubed there. So you can tackle each piece individually that way. This would be 5 and a 1. Get rid of the smaller powers and then subtract what you got rid of from the other ones. So this would become 1 and 1. This would go away. This would be a 2 and a 2 there. And then this would be a 2 and a 1. This would go away. That's a 6 right there. So this would become a 3, and this would become a 1. So let's make sense of what we have left there. We've got on the top, everything on the bottom canceled. We have 5a squared b to the first, which we just would write like that. We don't need the over 1 into the first power. We leave that out in a fully simplified expression. We have a squared b squared for that one, and then we're subtracting, so minus that, and then minus 2 a to the first, or just a, and then b cubed. We'll look for some like terms. I see a squared b, which is not the same as a squared b squared, and then here ab cubed, not the same either. So we don't have any like terms. There's nothing else I can combine together and simplify. It looks like we got that one. Moving on to 61, factoring the polynomial. If this helps you, do that. If it helps you to write out the factors, do that. So the factors of 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. And we're looking for one of those combinations that adds to 10. Everything is positive here, and that's going to be your combination. So you could just do this, you could just do this, you could do both things, you could do neither thing. For me, this is just things that can help you find the right combination. So if you find the right combination, write that down. We'd have x times x is x squared, x times 6 is 6x, 4 times x is 4x. Together you have 10x then, and 4 times the 6 is 24. Do the same sort of thing here. If it helps you to write the factors of 63, you could do that. But 7 and 9 would be the factors of 63 that either added or subtracted somehow give you 2, but we need it to be negative 2, so we need the bigger number to be the negative number there. So this would become a plus 7 times a minus 9. For this one, we're looking for the factors of 60 that multiply together to give you, well, that add together, to give you 4. And if you think of 6 and 10, if one of them was negative, that would give you a negative 60 here, but we need them to add to positive 4. So it's got to be the smaller number this time, being the negative 1. This would be y minus 6 and y plus 10. And remember, the order that you write the factors in could be reversed. So you could write y plus 10 first and then y minus 6. Either would be correct. And then on this one, we're looking for negative 72 and negative 14. This one, it might help you to write out the factors. The right combination that would work, though, would be 18 and 4. 18 times 4 is 72. But then negative 18 times 4 would be negative 72, and it would also add to negative 14 like we want. This means that this is your answer on this one. 65. Find the solution. So we're still going to factor. So if you do 42 and 17, if you think about the factors there, we would have 14 and 3. That would multiply to 42 and add to 17. So you could split this up like this. And then you're thinking, what makes this factor 0? Because that would make the whole equation 0. So negative 14 would do that. And then what makes this factor 0? That would be negative 3. So those are your two solutions. Over here, we need one side equal to 0 first. So you'd have x squared plus 4x minus 32 equals 0. From there, you can do your x method if that helps you. You can write out the factors if that helps you. Whatever you find helpful to do this, go ahead and do that. So x plus 8, though, and x minus 4 would be the right combination. And this one, negative 8, would make that factor 0. Positive 4 would make this factor 0. So those are your two solutions there. Factoring polynomials where a does not equal 1, I think the easiest way to do this is by grouping. So if you multiply a times c, put that there, and then negative 11, put that there. Think of the combination, it would be negative 6 and negative 5. So we split that one into these two numbers. Split that middle term into those two as factors or pieces, and we'd have negative 6x minus 5x plus 15. So that's still equal to what I started with. We just broke the middle term up, and then the reason for doing that, now we can use grouping. We can put these two together and think of what can be factored out of those two, 2x, and you'd have x minus 3 left. If we think of those two together, what can you factor out of those two? Looks like a 5, and if that first term is negative, always take out the negative with it. If you factor out a negative 5, you'd have x minus 3. As long as these are the same right here and here, that means you probably did it right. Because then we're going to put the outside the parentheses stuff together in one factor. The inside the parentheses stuff is in the other factor. And since each piece is being multiplied by x minus 3, 2x is being multiplied by x minus 3, negative 5 is being multiplied by x minus 3. This is equivalent to that. So that would be our answer there. We should be looking for GCFs as we do these problems too. There was no GCF here. There is no GCF here. If that was 12, we could take out a 6 out of everything. It's going to make it a lot easier if you take out those GCFs first. But there's no GCF, so we do a times c, and then negative 13. The middle term goes there. This would be negative 9, and negative 4 would be the right combination there. So split that middle term up into those two pieces. Group them together. Factor out what you can out of each group. Make sure you factor out a negative if the first term is negative, and you're left with this. If you do that, you'd have 3x minus 2 times 2x minus 3. 69. Find the solutions here. So this one, look for that GCF. I don't see any GCF. You got one side equal to 0. So let's try this and see if this works. So we'd have negative 16 times 3, so a times c, since a is not 1. So that's negative 48. Make that a little clearer there, negative 48. And then put your b on the bottom. And there is a combination that works for that. 8 and negative 6 would work just fine there. So we would have this middle term being split up into plus 8h and minus 6h. And then minus 16 equals 0. Use your grouping. Factor out what you can out of each group, and h can come out there. And a negative, excuse me, negative 2 can come out there. And that is an h, so that would be 3h plus 8 there as well. So we put the outside the parentheses stuff together. Each term being multiplied by that would be an equivalent thing. And then what would make this factor equal to 0 if you plugged in 2 minus 2. And then for this one, if you want to write 3h plus 8 equals 0, subtract 8 from both sides and then divide by 3. You can do that. The shortcut that we learned, you can also just look at the opposite of that, write the opposite of that number, so negative 8, and then divide it by that number, 3. So either way, you get the same answer. Those are your two solutions there. For 70, we need one side equal to 0 to try to factor stuff first. So I'm going to subtract 6a and subtract 12 from both sides. I'd have 8a squared minus 22a minus 12 would equal, these would cancel, equal 0. Here I can take out a GCF, so I'm going to do that to make things a little simpler later. I can factor out 2 of everything, out of everything. I'd be left with that. So at that point, a is not equal to 1, so I got to do a times c. And then, can I think of a combination there that'll work? So I would have, if you think that through here, I think I did something. Did I do something wrong there? What am I missing here? Yeah, I should have done a plus 12 there. There we go. So this would be a plus 6. That'd be a positive 24. That makes more sense then. So we have negative 3 and negative 8. And this would be, we're going to take that middle term again and split it up into those two as the factors. So break that apart. 4a squared minus 3a minus 8a plus 6 equals 0. And then use your grouping. So group those together, group those together. That 2 keeps coming down. Now you're going to take out an a out of those first 2. Take out a negative 2 out of those last 2, and that would be 4a still left, and minus 3. So these are the same right here and here. That's a good thing. We'd have 2, and then a minus 2 is outside the parentheses stuff. That goes together. 4a minus 3 equals 0. There's no way to make 2 equal to 0, so really you could divide everything by 2 to get rid of that, or just leave it there and not think about that, because there's no way to make 2 equal to 0. So 2 is one factor, no way to make it 0. A minus 2 is another factor. Plugging in 2 would make that factor 0. And then if we use our shortcut and do the opposite of that number is 3, divide it by that number is 4. If you want to do 4a minus 3 equals 0 and solve, add 3 to both sides, divide by 4, you have the same answer either way. So those two numbers are your solutions there. Number 70, if we're trying to factor each polynomial, here we have a difference of squares. So the shortcut way there is to just take the square root of each part, and you're going to have one being a plus and one being a minus. The square root of that would be 4x, and the square root of that would be 9y. So one will be 4 plus 9y, the other one will be 4x minus 9y. The other way to think of that, you could think of this as 16x plus 0xy minus 81y squared, and then you could do this sort of thing where you have negative 81 times 16. That's going to get pretty messy pretty quick. So I think it's good to know that difference of squares shortcut. So it's square root here, square root there, put it there, put it there. One's plus, one's minus. On this one, we could take out a GCF of 2 first of all. So 4x squared minus 25d squared. And then from there, you can take the square root of each part. And again, one is going to be plus, one is going to be minus. The square root of that is 2x. So I'll put that in the front. The square root of that is 5d. So I'll put that in the last spot. That would be a fully factored answer. Number 73, graph and label each equation. If you look at this one, the slope is 3 over 4, and the y-intercept is 2. All of these, negative 2, excuse me, all of these appear to be in slope-intercept form already. This one, the slope is going to be, that's like an invisible 1 right there, so negative 1, or you can think of that as negative 1 over 1. The y-intercept is 1. And then on this one, you've got a slope of negative 5 halves. You got a y-intercept of negative 4. So we'll go A, B, and C when we label them. Start with the y-intercept. Always start there, and then graph another point with the slope in mind. So up 3, right 4. If I went down 3, I'd be going left 4. These are all equal to, so they're going to be solid lines through those points. This one, y-intercept at 1, and you got a slope of negative 1. So negative 1 over 1. That pattern would continue going downhill as you move from left to right. and you'd have, connecting those dots, you'd have a line that looks like that. Again, you should use a straight edge, but I'm just trying to get you the gist here. That is A, that is B, and then C starting at -4. 1, 2, 3, 4. And then down 5, right 2. If you went down 5, you'd go off the graph. So if we go up 5 instead, 1, 2, 3, 4, 5, and left 2, that does the same thing. 1, 2, 3, 4, 5 gives us the same line. And oops, there we go. And that would be line C. Number 74, getting close here. Combine into one fraction, leaving answers in a completely factored and simplified form. On this one, we think of this as one factor. X minus 2, we think of x minus 5 as another factor. To combine equations or expressions like this together, we would have to get a common denominator if we're adding or subtracting. So a common denominator would include both of these factors. X plus 2, I would have to multiply this one by x plus 2 on the top and bottom, and have to multiply this one by x minus 5 on the top and the bottom. If I do that, I'm left with 7 times x minus 5 over x plus 2 times x minus 5 minus 4 times x plus 2 over x plus 2 times x minus 5. So dealing with rational expressions here, we got to get those common denominators. Once they're the same, now we can combine them together. So now I have x plus 2 times x minus 5 all together on the bottom. So just like more simple example, 1/4 minus 2/4, you would just say the bottom would be 4, and then you'd have 1 minus 2, so you had -1. That's not related directly here to the example, but indirectly the idea is the same. You got a common denominator, you can just add or subtract the numerators. This 7 will get distributed through, that'd be 7x minus 35, and then this, careful here, this is a common mistake I see, if there's a negative sign, don't forget to distribute that negative with the coefficient or with the value there. So this would be -4x minus 8. And if you simplify that one more step, you can combine like terms on the top. 3x minus 43. There's nothing that can be factored out of both of those, so this would be a fully factored and completely simplified form for that question. And then this one, it looks like we could break this apart by factoring the denominator here. Let's try that. If we had a 10 and a 7, 2 and 5 would work. So if we rewrite this, this would be the same thing as 3 times y plus 5. I'm going to leave a little blank spot here. You'll see why in a second. And then y over y plus 2 times y plus 5. So I notice here I've got y plus 2 and y plus 5, but I notice here I only have y plus 5. If I multiply this by y plus 2 on the top and the bottom, then I will have a common denominator for these. Then I can just add the tops together from there. So this is y plus 2, top and bottom. You've got 3 times y plus 2 plus y. This is going to be all over the common denominator we have there, y plus 2 times y plus 5. And if you wanted to write it as y plus 5 times y plus 2, that would be just as good. You can distribute that through. You'd have 3y plus 6 plus y, and then y plus 2, y plus 5. Combine like terms, and you're left with 4y plus 6 over y plus 2, y plus 5. But it says completely factored in simplified form. So we can factor a 2 out of both of those things here. So you'd have 2 times 2y plus 3 over y plus 2 times y plus 5. The reason why we want to factor everything is because sometimes you'll get things to cancel still later on, top to bottom. Here it didn't happen. This would be our fully factored and simplified answer, but we do that to make sure. And we're there. We made it to the last couple problems here. This is x and x plus 3. This is 1/4. I'm leaving some blank spaces here because I want to get some common denominators. And then I'm going to put this right here in a factored form. I've got 2 times x plus 3. So I'm going to look for what factors I'm missing. Here I'm missing, well, this is going to be a 4. And so I'd have to have 4 times x plus 3. So I'm going to multiply by that top and bottom. I'd have to have a 4 here to get 4 times x plus 3. And then this is 2 times x plus 3, so I would need to multiply that by a 2 on the top and the bottom. Well, let's see what happens when I do that. So I've got 4x and then 4 times x plus 3, not 4x plus 3. So 4 times x plus 3 plus, and then 1 times that would just be x plus 3. And this would just be 2x, and then 2 times 2 would be 4. So it'd have 4 times x plus 3 there. Now we have all common denominators. When we're solving rational expressions, get that denominator the same, and then you can just cross them out. It's the really nice thing about solving with rational expressions. And then from there, we have that. We've got 5x plus 3 equals 2. Something you'll learn about in Algebra 2 is something called extraneous solutions. We're not going to deal with those here with the rational expressions. But later on, you're going to have to take your answers and plug them back in to check and make sure that they actually are legitimate answers and aren't discontinuities in the function itself. But you'll learn a lot more about that in Algebra 2. So for right now, just get those denominators the same, cross them out, simplify the tops, solve. You've got -1 equals x. And then on this one, last one here, x times x plus 5, going to leave a blank space, and 3 there, going to leave a blank space, and then you have 2 times x plus 5 here. So it looks like on this one, we've got a 3, we've got a 2, so 6 would be a common denominator for the non-variable part. So I'd want to multiply this one by 6 over 6, this one by 2, and also an x plus 5, because that's going to be missing both spots. So 2 times x plus 5 there, and then this one would be missing a 3. So if we do that, we're going to have 6x over 6 times x plus 5 minus, and this would be 2 times 2, that'd be minus 4, and x plus 5 there. You'd have 3 times 2, that'd be 6 times x plus 5. That would equal 3 times x, 3x, and then 2 times 3, 6 times x plus 5. Those denominators are now the same, so let's get rid of those and then just simplify the tops. Careful here to distribute the negative with the 4, and you've got 6x minus 4x minus 20 equals 3x. I can combine like terms there. I'd have 2x minus 20 equals 3x. If I subtract 2x from both sides, I would be left with -20 equals positive x dividing by, no, I don't need to divide by anything. X equals -20. If that was a negative x, then I would divide by -1 and do the opposite of what I'd see there. That does it. Go back and review as you see fit. Review by printing out new copies from our website of the review, and go back and practice those problems again and again and again until you feel confident. But please let me know if you saw any errors in there. Comment in the comment section below. And thanks for your input. Thanks for watching. Hopefully you found it helpful, especially if you're one of my students preparing for our Algebra 1 final coming up. Hope you're doing well. Hope you have a good night, good day, whatever time of the day it is for you. And I'll catch you later here on Wagner Academy.